Section 3.1, Properties of Matter. The objectives are to identify the characteristics of a substance, distinguish between physical and chemical properties, and differentiate among the physical states of matter. Some vocabulary review will be density, and some new vocabulary you'll come across is states of matter, solid, liquid, gas, vapor, physical property, extensive property, intensive property, and chemical property. As you know, matter is anything that has mass and takes up space. Everything around us is matter, including the things we cannot see, such as air and microbes. For example, table salt is a simple type of matter that you're probably familiar with. Table salt has a unique and unchanging chemical composition. Its chemical name is sodium chloride. It is always 100% sodium chloride, and its composition does not change from one sample to the other. Salt harvested from the sea or extracted from a mine always has the same composition and properties. Recall from Chapter 1 that a matter with a uniform and unchanging composition is called a substance, also known as a pure substance. Table salt is a pure substance. Another example of a pure substance is pure water. Water is always composed of hydrogen and oxygen. Seawater and tap water, on the other hand, are not pure substances because samples taken from different locations will often have different compositions. That is, the samples will contain different amounts of water, minerals, and other dissolved substances. Substances are important. Much of your chemistry course will be focused on the composition of substances and how they interact with one another. Imagine you are sitting on a bench, breathing heavily and drinking water after playing a game of soccer. You are in contact with three different forms of matter. The bench is a solid, the water is a liquid, and the air you breathe is a gas. In fact, all matter that exists naturally on Earth can be classified as one of these physical forms, which are called states of matter. Each of the three common states of matter can be distinguished by the way it fills a container. Scientists also recognize other states of matter. One of them is called plasma. It can occur in the form of lightning bolts and in stars. A solid is a form of matter that has its own definite shape and volume. Wood, iron, paper, and sugar are all examples of solids. The particles of matter in a solid are tightly packed. When heated, a solid expands, but only slightly. Because its shape is definite, a solid might not conform to the shape of the container in which it is placed. If you place a rock into a container, the rock will not take the shape of the container. The tightly packed particles of a solid make it incompressible. That is, it cannot be pressed into a smaller volume. It is important to understand that a solid is not defined by its rigidity or its hardness. For instance, although concrete is rigid and wax is soft, they are both solids. A liquid is a form of matter that flows, has constant volume, and takes the shape of its container. Common examples of liquid include water, blood, and mercury. The particles in a liquid are not rigidly held in place and are less closely packed than particles in a solid. Liquid particles are able to move past each other. This property allows a liquid to flow and take the shape of a container, although it might not completely fill the container. A liquid's volume is constant. Regardless of the size and the shape of the container in which the liquid is held, the volume of the liquid remains the same. Because of the way the particles of a liquid are packed, liquids are virtually incompressible. Like solids, however, liquids tend to expand when they are heated. A gas is a form of matter that not only flows to conform to the shape of its container, but also fills the entire volume of the container. If you fill a container with gas and close the container, the gas will expand to fill the container. Compared to solids and liquids, the particles of gases are very far apart. Because of the significant volume of space between particles, gases are easily compressed. You are probably familiar with the word vapor as it relates to the word gas. However, the word gas and vapor, while similar, do not mean the same thing and should not be used interchangeably. The word gas refers to a substance that is naturally in the gaseous state at room temperature. The word vapor refers to the gaseous state of a substance that is a solid or liquid at room temperature. For example, steam is a vapor because water exists as a liquid at room temperature. You are probably used to identifying objects by their properties, their characteristics, and behaviors. For example, you can easily identify a pencil in your backpack because you recognize its shape, color, weight, or some other property. These characteristics are all physical properties of the pencil. A physical property is a characteristic that can be observed or measured without changing the sample's composition. Physical properties also determine pure substances. Because substances have uniform and unchanging compositions, they also have consistent and unchanging physical properties. Density, color, odor, hardness, melting point, and boiling point are common physical properties that scientists record as identifying characteristics of a substance. Physical properties can be further described as being one of two types. Extensive properties are dependent on the amount of the substance present. For example, mass is an extensive property. Length and volume are also extensive properties. Density, on the other hand, is an example of an intensive property of matter. Intensive properties are independent of the amount of substance present. For example, the density of a substance at constant temperature and pressure is the same no matter how much of the substance is present. A substance can be identified by its intensive properties. In some cases, a single intensive property is unique enough for identification. Some properties of a substance are not obvious unless the substance has changed composition as a result of its contact with another substance or the application of a thermal or electric energy. The ability of a substance to combine with or change into one or more substances is called a chemical property. Iron forming rust when combined with the oxygen in the air is an example of chemical property of iron. Similarly, the inability of a substance to change into another substance is called a chemical property. For example, when iron is placed in nitrogen gas at room temperature, no chemical change occurs. Every substance has its unique set of physical or chemical properties. Copper can be shaped into different forms, which is a physical property. When copper is in contact with air for a long time, it reacts with the substance in the air and turns it green. This is a chemical property. The properties of copper listed in Table 3.2 might vary depending on the conditions under which they are observed. Because the particular form or state of a substance is a physical property, changing the state introduces or adds another physical property to its characteristics. It is important to state the specific conditions, such as temperature and pressure, under which observations are made because both physical and chemical properties depend on these conditions. Resources that provide tables of physical and chemical properties of substances, such as the CRC Handbook of Chemistry and Physics, generally include the physical properties of substances in all the states in which they can exist. Consider the properties of water, for example. You might think of water as a liquid, which is a physical property, which is not particularly chemically reactive, which is a chemical property. You might also know that water has a density of 1 gram per cubic centimeter, which is a physical property. These properties, however, apply only to water at standard temperature and pressure. At temperatures greater than 100 degrees Celsius, water is a gas, which is a physical property, with a density of about 0.0006 grams per cubic centimeter, which is a physical property that reacts rapidly with many different substances, which is a chemical property. Below 0 degrees Celsius, water is a solid. That's a physical property, with a density of about 0.92 grams per cubic centimeter, which is a physical property. The lower density of ice accounts for the fact that icebergs can float on ocean. Clearly, the properties of water are dramatically different under different conditions. Section summary. The three common states of matter are solid, liquid, and gas. Physical properties can be observed without altering a substance composition. Chemical properties describe a substance's ability to combine with or change into one or more new substances. External conditions can affect both physical and chemical properties.